Welcome to The Explainer. Today we're venturing out, way out, into the vast, dark spaces between the stars to find some of the galaxy's loneliest inhabitants.
So let's just jump right in with a huge question. Picture this, a world with no sun, no dawn, no dusk, just endless, silent night. Could a world like that be anything more than just a frozen, lifeless rock?
To even begin to answer that, we first need to get our heads around what we're even talking about. Let's introduce the cosmic nomads of our galaxy.
Okay, so a rogue planet. What is it? Well, simply put, it's a world that isn't gravitationally tied to any star. It's a true wanderer, just drifting through space, all on its own.
And scientists have come up with a bunch of names for them, and they all kind of capture that lonely vibe. You'll hear them called free-floating planets, wandering planets, starless planets, even cosmic orphans. Each one really paints a picture, doesn't it?
So, the big question is, where do these things come from? Turns out there are basically two possible backstories, and they're both pretty dramatic.
Okay, so path number one, it was born in isolation. It formed all by itself from a cloud of gas, almost like a star that just never quite ignited. Path number two is even wilder. It was exiled from its home. It formed in a normal star system, just like Earth, but then, boom! Some kind of gravitational chaos kicked it out into deep space.
And here's the really cool part. A planet's mass is a huge clue to its past. If we find a really massive rogue, like a gas giant, it probably formed on its own, like one of those failed stars. But the smaller, rocky ones? Yeah, they were almost definitely ejected, kicked out of their own solar systems.
Now, you can probably guess that finding these things is, well, it's a massive challenge. I mean, think about it. How in the world do you find a dark object in the infinite darkness of space?
Well, astronomers have this absolutely brilliant trick up their sleeve called gravitational microlensing. It's wild. So imagine a rogue planet happens to pass exactly in front of a distant star from our point of view. The planet's own gravity acts like a lens, literally bending and magnifying the star's light. So for just a moment, that background star gets a tiny bit brighter. And that little flash of light, that's how we know an invisible planet just drifted by.
And get this. This isn't just some theory on a chalkboard, it actually works. In 2020, they used this exact method to find something amazing. OGL 2016-BLG-1928. This was the first real candidate for an Earth mass rogue planet. An Earth mass. We're literally hunting for ghosts with gravity, and we're finding them. Okay, so we can find them. But that's just step one. It all comes back to that central question we started with. How could a sunless world avoid just freezing solid?
This idea might sound brand new, but scientists have been kicking it around for a while. Way back in 1998, a scientist named David Stevenson was already asking if it was possible for life-sustaining planets to exist out there in the void.
So, what's the secret to staying warm? It turns out they could have their own internal heat engines. First off, you've got radioactive decay. Elements breaking down in the planet's core, releasing a steady trickle of heat. Then there's tidal heating. If the rogue planet managed to hang on to a big moon, the gravitational squeezing and stretching would generate a ton of internal warmth. And finally, you could have a super thick atmosphere that acts like a giant planetary blanket, trapping all that heat inside.
And here's why that's the absolute game changer. That warmth, it could be just enough to keep a huge ocean of liquid water from freezing, hidden under a thick shell of ice. And it could power hydrothermal vents on that ocean floor, creating a constant chemical buffet perfect for microbes to thrive. It's a setup we see right here on Earth, in our own deepest oceans.
Okay, but are these just rare oddities, or are we talking about something more common? This is where the numbers get really, really wild. Some of the first estimates were already pretty shocking. They suggested that for every single star in our Milky Way galaxy, there could be at least 2 rogue planets the size of Jupiter. Just think about that for a second. 2 giant worlds for every single star. But remember, that was really counting the giant ones. What happens when you include all the smaller planets? Well, the latest research suggests that free-floating planets could actually outnumber all the planets that are tied to stars. The drifters are more common than the ones with homes. So what's the grand total? The estimates now range from the tens of billions all the way up to the trillions. Our galaxy could be home to literally trillions of these hidden, wandering worlds. So I want to leave you with this final kind of mind-bending thought.
If there are trillions of these hidden worlds out there, and if even a fraction of them have a warm, wet interior powered by their own energy, what does that mean? Could it be that life is far, far more common in our galaxy than we ever imagined?